Hi, folks. Our discussion today in class is going to go something like this. If you have a couple friends and you're standing around, you might, veer into the area of comparisons. So you would say, like, hey, maybe this is you right here. Okay. And you're saying, I'm older than my friend that's standing to my left. So this is friend number one, we'll call her. And then this is friend number two over here. And so let's put that down. You are greater than friend number one. In other words, age, your age. Let's put that down. Your age and number one's age. Okay, you're greater than number one's age. What if number one is older than number two? I know this inequality doesn't make sense. One is not bigger than two, but friend number one is their age is bigger than friend number two's age. Well, couldn't you say that your age is greater than friend number two? Like you have to be older than this friend over here. And our brains do this so quick, we don't really think about this a whole lot. But comparisons are completely normal, and we're quite often in inequalities with each other. Someone's taller than somebody else, or somebody's older than somebody else, right? And the transitive property is what we just discussed right down here. It gets a special name. If you're older than friend one and friend one's older than friend two, then you are older than friend two. Okay, so I hope this doesn't sound too complicated, but mathematicians give them names: the transitive property or the addition property of inequality. Let's say 2 years from now, or 5 years from now, you plus 5 years is still going to be bigger than your friend number two, plus 5 years. So you can add the same amount to an inequality and still have an inequality that's true, right? So you don't have to move inequality signs around. Pretty simple. You could also subtract, like 5 years ago. You 5 years ago was still older than friend two 5 years ago. So we could have like you minus 5 years is still bigger than friend two minus 5 years, right? So this is age of your friend two. This is your age, right? Inequalities are pretty straightforward. We use them all the time. So how does this apply to our triangles? Well, here's a kind of an interesting idea. If we look at GeoGebra for a second, I want to flip over to GeoGebra, and I'm going to ask people in class today to investigate this triangle that I've shared with them. It's attached to our Google Classroom assignment. So you see that each one of the angles are a different measure, and you see that each one of the sides are a different measure, right? Well, what kind of comparison can be made from these 6 values right here, these 3 interior angles and these 3 side lengths? Somebody would say, well, look, here's the smallest angle. There's the smallest side, the shortest side. Here's the next largest angle. Here's the next largest side. Here's the largest angle. Here's the largest side. So that's what the triangle inequality is all about. That the smallest side is going to be across from the smallest angle. So in my drawing, I'm going to say that this one is the smallest. Okay. So then this angle right here would have to be the smallest. And then if you had a medium sized length, let's say this one's the medium one right here. Okay. This might not match up exactly with the way GeoGebra was looking here a second ago. Then this one over here might be the medium angle. And then if you had a largest side, okay, then this would be the largest angle right up here. Okay, I'll put a couple different tick marks here so that you can see none of these angles are equal to each other. So this would be the largest one right up here. So the largest angle is across from the largest side, the smallest angle is across from the smallest side, and the medium side is across from the medium angle. That's pretty straightforward. That's triangle inequality property. And I hope that makes sense. Now, what's this vocabulary word all about? Exterior angle. Well, let's extend this side right here. Let's extend it out. All right, let's extend that out. And let me see if I can change to a different colors. I've used 3 colors here. I'm going to go to like orange. So my exterior angle is over here. This guy right here is my exterior angle. Why don't you put like an arc with a single tick mark through it? This exterior angle, let me zoom in on that guy for just a second. Why is it called an exterior angle? Well, it's on the outside of the triangle. Okay. So the exterior angle is on the outside. These are called interior angles because they're inside the triangle. This one's called an exterior angle because it's on the outside of the triangle. And if you look at like this, gosh, what color is that? Like a mustard color or an orange color? Orange plus the black. Okay, so look at the smallest angle over here. I call it the smallest angle. The black angle and the orange angle added together. Don't they have to add up to be 180 degrees? So let's just put like a little symbol down here, like orange plus black has to equal 180 degrees. Would you agree with that? The orange angle plus the black angle, because this is a nice straight angle, right? Did you know that the sum of the interior angles equals 180 degrees? All right, the sum of the interior angles of any triangle are 180 degrees. Let me just show you that real quick. If we added this angle, and this angle together, they should be 180 degrees. And they're at the bottom of my list down here. And quite often we give them Greek letters for angles. So I'm going to go right in here. I'll show you something kind of cool on GeoGebra. Right down here, there's this little button where you can switch to the Greek letters. So I'm going to go beta plus gamma plus delta, and I'm going to hit enter. And you can see the three angles equal 180 degrees. Now, sometimes this seems like a bit of a show. Like, really, Nelson? Is that true? Like, if I start moving this angle over here around, I don't see any change in the 180. Well, that's because it's always 180. No matter where you move this triangle here, the sum of the interior angles is 180 degrees. So what does that mean? Well, black plus blue plus red. Okay, let's put those three down. Black plus blue plus red has to equal 180 degrees, right? So we'll look at this for a second. I just wonder how could I look at, like, see where I've got this black and the orange mustard color, whatever you want to call it, black plus mustard, but then I got black plus blue and red here. What if I replaced, okay, let me let's see here. Let me put like a little bubble around this thing right here. What if I replace that black right there? Let's think about this for a second. If I replace the black with how should I say this? I'm going to replace let me try that. Let me try that a different way. Let me undo that. I had kind of a little lockup how to make this clear. I'm going to replace the orange with blue and red, because you see black plus blue and red equals 180. Well, how about orange plus blue and red? Would that be equal to 180? Let's investigate that for a second. The orange, shoot, my orange color is gone. Let me see if I can copy and paste it. Hold on. No, it won't let me do that. Ah! Let me see if I can grab it like this. Oh, no, it won't let me do that either. Control C, Control V. I'm going to make a copy of it. There we go. Okay, so I've got my orange angle. And then instead of having black, I'm going to add, because I could just, I could replace it with the blue and the red, couldn't I? Couldn't I put down plus blue and red? And no, I can't really do that. That doesn't make sense. Let me undo my thinking for a second. What I'm trying to say is that the mustard color has got to be equal to the blue and red. Okay, that's what I'm trying to say. Look, this mustard color right here and the blue and the red have to be the same, because we had black plus these two equals 180. We got black plus the orange or the mustard equals 180. So blue and red have to equal the mustard color. That's what I'm really trying to say. Sorry about that. So I hope I'm making it clear that the exterior angle equals the sum of the two remote interior angles. I'm going to hopefully do better in class. So let's see if we can show that here. If I add the blue and the red colors together, so blue is BAC angle. So where's BAC angle? BAC is right here. It's that gamma one, right? So if I come right here and I go, let's see, I want the gamma angle. So there's a gamma right there, plus the other one. Oh, shoot, I can't see it. Plus ABC. What's ABC? Where's ABC at? Here it is right here, CBA. That's the delta angle. So I'm going to go plus the delta angle. And let's see if it comes out to be that 100 and some degrees. Okay. So 122.59. 122.59. These two are always going to equal, if you add them up, this exterior one out here. So this exterior one has to be bigger than one of these by itself. This 122.59 is going to be bigger than 75.66. 122.59 is going to be bigger than 46.92. It's kind of a subtle little thing, and it might seem unimportant to you, but it's a way for us to practice our deductive reasoning skills. Okay? So they're going to ask us questions like this in homework. They're going to say, list the angles that satisfy the stated condition, justify your reasoning using the exterior angle inequality theorem. So what measures are less than angle 1? Well, angle 1's an exterior angle. So I know there's some extra lines in here. Like look, I'm going to highlight the triangle that's of importance. This triangle right here is the one that we're focused on right now. Why am I focused on this triangle and not this little triangle right in here? Well, angle 1 is that mustard color. Let's see if I can switch over to the mustard color. This angle 1 is our exterior angle right out here. Okay, that's our exterior angle. So this here is our interior angle. I don't know, one of them was red, wasn't it? I think. Let's switch back up to our notes and look again. So yeah, one was red and one was blue. So when I come down here, I'm going to make this one, I don't know, red. This angle right here, red. And then this angle right down here, I'm going to make it blue. So the mustard color is equal to these two added up. So by itself, it must be, the exterior angle must be bigger than the red one. The exterior angle by itself must be bigger than the blue one. So what I'm going to put down here for my answers is angle 3. That's my angle symbol right there. Angle 4. That is a 4, I think, right underneath. 5 and 6 as well. Angle 5 and angle 6. They all must be smaller than angle 1. All 4 of these must be smaller than angle 1 because they are what are called, like added together, 3 and 4 are a remote interior angle to angle 1. Angle 5 and 6 are a remote interior angle added together to angle 1. Very tricky problem, right? Let's look at an easier problem for a second. Let's look at an easier problem. Question 2 on your homework, I think, looks something like this. It says, here's a triangle with 3 different side lengths. And they want you to select the angles and sides of the triangle that are listed in order from smallest to greatest, smallest to largest, okay? So, well, look at this. This is the smallest side. This is the medium side. This is the largest side. So across from the smallest side has to be the smallest angle. This guy right over here has to be the smallest angle. So I'm going to put like an S right here, smallest angle. Across from the medium side length is the medium angle. This is the medium angle up here. And across from the largest side has to be the largest angle. So if we're looking for angles in order from smallest to largest, we're going to go TRS. So which one has TRS? Well, this one does right here. These two both have TRS, don't they? TRS. Now we're looking to put the sides of, sides in smallest to largest. So smallest was RS, medium is ST, right? So RS, ST, and the largest one is RT. So this must be the correct answer right down there at the bottom, right? I hope I'm making this clear, guys. We're trying to compare side lengths and all that kind of stuff in these triangles. When you look back, the most complicated idea is this idea of an exterior angle. the exterior angle is going to be larger than the two remote interior angles by themselves. So the orange is going to be larger than the blue. The orange is going to be larger than the red. The reason why is because the orange plus the blue, or the orange equals the blue and the red added together. That's what I was trying to show right here, that the orange is equal to the blue and the red added together. All right. Whew, man. I hope I made that clear. Thanks for watching my video, and good luck on the homework.